Hello everybody, it's Michael from Archimede Design and welcome to this Fusion360 tutorial on parameters. What we're going to do is use what we would call parametric design tools to design a grommet and be able then to just modify those parameters to pretty much create a grommet of any size. Yeah, it's a grommet. You can find grommets pretty much readily available. Finding them on McMaster-Carr, for instance, which we will actually be referencing, and we'll show that in a little bit. However, there are instances where maybe you're doing a very unique design with maybe a larger custom grommet that you want to design. Lots of different reasons why you might want to do something on that has your own flair to it, and then scale it appropriately to your application. So we're just going to take some basic dimensions from McMaster-Carr as our parameters, and then we will be doing this grommet. The parameters are a very useful tool, especially if you want to reference certain dimensions on, say, a primary component, and secondary components are referencing those parameters. So when you make a change to that primary component, all the subcomponents will also adjust in their size and design. But we won't be getting that deep into this video. We're just going to do it on one particular component. But, let's get started here. So first thing we're going to do is we're going to take a look at what dimensions are most common for a grommet. So we're going to launch a browser window here, and we're going to look up McMaster-Carr. If you're there often, it's mcmaster.com. Like that to come up. So if you haven't really spent a lot of time on Fusion and you're like, oh, I want to find fasteners or things that I can install into my model, McMaster-Carr is a really great resource because oftentimes, especially fasteners and certain wear, are available to download as 3D models that you can insert right into your model. So that's a really great tool. Yeah, there are a lot of things here. We could try to hunt for grommets by clicking on these different boxes, but we're just going to type it in. That's the easiest way to come about it. And it's going to bring up all kinds of different grommets here. We are really just going to stick with a typical push-through type flexible grommet. That's what we're going to do for this exercise. So if we click on that, lots of different choices and a few different styles that can be chosen here on McMaster-Carr. We're pretty much just really going to be doing kind of like style 1, style 2. But so what are the main parameters that we're interested in? Let's just hover over this. So really, we want to look at these dimensions. We have, it's for a certain hole size, A, what's the material thickness, B, what's the inside diameter, C, what's the overall flange diameter, D, and then the overall height, E. So those are the parameters that we're going to use in our Fusion file. So the first thing to do now is to go in and start the drawing and define those parameters. So let's go into Fusion. We have a new file started here, and right off the bat, I'm just going to save this, and let's call this grommet parameters example. Save that. Now, looking at that design, pretty obvious from the cross-section how we're going to want to design this. We could do just what we see here in the outline, but really, the best thing is we're going to evolve this around an axis. So we really only need to do half of it. And technically, we could even just do a quarter of it and use a mirror option, but we'll just do half of it. That way we use kind of our dimensions that are given to us fully. So first thing is to start a drawing. I'm going to do this on the Z, and for me it's my ZX axis. So we're going to do that. And just so you know, our document settings here, we are in inches. So if you need to change that, just click on this little box to the right, and you can change it to inches from millimeters or to millimeters if you need to. Now that we're in drawing environment, where are we going to start with this? And the way I would go about it, and there's lots of ways people could go about it, but I want to get the basic form in place just to kind of get an idea of what it's going to look like. And for me, I'm going to start with a center rectangle, and I'm just going to kind of make a box out there. Then I'm going to do a center or rectangle corner, and just going to do a couple of those. They don't necessarily have to be equal to each other. You'll see that the entire drawing is not at all fully. You'll see that your drawing right now is not fully defined, not fully constrained. That's why I have all the blue lines. We'll get to that in a second here. So you can find parameters in the sketch environment under modify, or actually in just the solid model or other environments as well, and add your parameters. And it's under here called change parameters. You click on that, this window will come up, and you can add your user defined parameters here. So we know we had an A diameter, which was the hole size, so hole diameter. So we'll call it hole diameter. And we're going to, for this, just start it out at 0.5 inches. We also know that we had the, the thickness of the material. So this was material, let's just call it thickness. And I'm going to call that, for now, I'm going to call that 1/8 of an inch. And then I think the other one was the inside diameter, so the ID. So we'll call it ID. And we're going to call that, for now, 0.25. And then I believe we had our flange diameter, just to make sure. D was the flange diameter, so that's the whole diameter of the grommet. So flange diameter, let's call that 1. And these may change. It might not look quite right, kind of weird as we start, but I'm just putting in some numbers for now. And then the last one was E, which was the overall height of the grommet. And let's call that, I don't know, let's do 3/8. And you notice you can type these in as decimals, or you can put them in fractions. Do as fractions, it's going to do this 3/8 times 1. If you're familiar with Fusion, that's just kind of how it does to assign the unit. So, all right, so we have these defined. Now, I'm going to start cleaning this up, and if you kind of hover on this, you can see there's a lot of overlapped sections, and I'm really just going to start trimming away some of the fat. So don't need that, don't need that, don't need that. There's a couple of them there. Don't really need these lines for now, because we're going to just reconstrain this whole thing. And there are a couple overlapped lines here. So we're just going to get rid of some of those and see if we can't get this. Oh, I missed that. So, all right, we'll extend that down. So there, we should just have those lines. So a couple things we're going to want to do here. We're going to want to constrain this so it's symmetrical across this axis. So just turn on our origin for now so we can see it. And I'm going to do a symmetrical constraint between this line and this line around that axis. And I'm going to do it around this line and this line around that same axis. If I try to scale this just by grabbing a corner, it's going to keep those in line with each other. So now we can start just applying our dimensions. So we're going to do a dimension from here to here. This was our inside diameter dimension. So you actually see this as a radius, not an inside dimension. So we're going to do ID, their parameter that we defined, ID divided by 2. And you're going to see it moved it to 0.125, which was half of the 0.25 we defined. We can now also define our flange diameter, but that is also divided by 2. And so now you can see, like, oh my gosh, what happened? It totally went, just because I haven't, these that I preset have not done anything yet. So they'll all move accordingly once we reset them. So that is our whole diameter, which I'm going to put right here. That whole diameter divided by 2. Break that in. And then we need to set our overall height, which was height. Let's see if we can get that again. And you're like, oh my gosh, it's looking crazy. What's happened? Don't worry, we're okay. We're okay. Now we're going to do this, the 2 blue lines, the ones that aren't defined. That was actually our inset for our thickness. So this is this. There we go. So we got that defined, but now we just have this other edge that's out here, and all we need to do is make this collinear with that. And now we have a fully defined cross-section of one side. So the next thing we need to do is think about, well, I want to put some radiuses on here. Maybe I want to use a standard radius, or just pick one just by setting the radius. You know, we could just go in and just make some radiuses and set them. But I do want to make a parameter around that radius. And then I also want to make that radius be affected by what this thickness is. Because if I have that radius and it's too large, and it goes beyond the, whatever thickness is here on one of the upper flanges, I could get an error. So let's go in and modify, and let's change parameters again. So what I'm going to do here is we're going to call this, add a new one. Let's call it Grommet radius, or rad, okay? So that grommet radius, I actually want it to be equal to basically the difference between the height, the thickness, bracket that and divide that by 2. So that's going to give me the thickness of just one of these flanges. So if I type in height, try it again. Let's grab that height minus thickness divided by 2. Now that, if you saw that when we were clicking on that, it actually gave me a value. It calculated it as 0.125, and you'll notice that our thickness is 0.125, or our height is 3/8. So what it did is it took that overall height minus that 0.25, and then gave us, and divided all that by 2 to get 0.125. And let's see here. So now let's okay that, and let's do a radius right here. And let's put in grommet radius. So you'll see that that grommet radius defined exactly at that point, at that size. However, if you look at it, we've lost some definition. It went completely edge to edge, and we might want to have a little bit of room still here where it's not exactly the same thickness. If if you actually look at the sketch here, you'll actually see on McMaster car that there is a little bit of a vertical portion there. So I want to go back, so let's just undo that. And let's go back to modify, change parameters. And here's where I like to add a parameter sometimes called for tolerance, or I call it tall. And you can have tall 1, tall 2, tall 3, depending on if you want to have different tolerances for different things. If you know that you have to have a certain tolerance between fit items, this is a great way to use a parameter. In this case, I'm going to have it as 1/32 and use that as a parameter. And then I'm going to modify my grommet radius to be -3 times tall. And you'll see now it changed that value to 0.031. And what we're going to see is a very small radius in this case. So if we go here and here, and we put grommet radius, you can see it gave us a nice small radius. I'm going to leave that there for a second. So it's a little small. I'd like to see it be a little bit bigger. So watch what happens if I go and change parameters. I'm going to change this function, and I'm just going to make it times tolerant, or minus the tolerance, not 3 times. And okay, and it automatically made that adjustment to that radius. We're going to do the rest of the other side of the radius the same way. Here and here. Guess I got to select it. And let's call that grommet radius. Good. Now, I kind of wouldn't mind having a little bit of a radius here and a little bit of a radius here, and on the inside, just pretty small. And let's just do a trick here, and let's just make that equal to tolerance. Let's do it out here and out here. There we go. So we pretty much now have our grommet cross-section defined. And we have our parameters defined. We'll pull these dimensions down so they're a little bit closer. And things are all set. Now, a couple things to keep in mind is right now there is this situation where I literally could change, let's go into parameters so we can see our parameters. I literally could change the thickness to be bigger than the height, and it could mess up the whole drawing. And the way you can get around that is by, instead of having the thickness defined, I should say the overall height, defined just by you putting in a number, we can actually make the overall height be a function of whatever the thickness is. So let's change that. So right now our thickness, our overall height is, we put it as 0.125. Or I'm sorry, the thickness. Our overall height was 3/8. So instead, what we're going to do is we're going to make it equal to, we'll just type it in here, is thickness times 2. And here, so by doing that, you can see where now it's going to define what that thickness is by whatever, or by whatever that height is by the thickness of your material. 2 is a little bit too small. You know, if we go to 4, it's going to make them kind of equal, be kind of too much. So we'll go with 3, which I think then puts us right back at 3/8. So now we have that ratio there. So if I change that thickness to 0.5, it's going to make the adjustments and make everything thicker. Now, you may want a higher thickness and still want that kind of still thinner flange, which is fine. And just go in here and change how that equation works. But overall, if you at least have an equation there, it won't let your your drawing, your sketch, all out of whack. So now we're defined. We'll keep it at that. And so the next thing is we just need to revolve this and make ourselves a solid model. So let's finish the sketch. Let's go into perspective view here, and we're just going to revolve that section around that axis 360 degrees. We're creating ourselves a new body, and it's rubber, right? So let's make it look like rubber. So I believe rubber is under the plastic, somewhere down here. Rubber black, sure, that's fine. Close that. So here we go, as we have ourselves a nice grommet. Let's custom size, custom holes. So that's that's great. Now let's imagine the situation is that I can't find the grommet that I have. I have a grommet that's supposed to be, have a hole, fit in a hole that's 3 inches in diameter. So let's look at what happens if we do something with that. So I'm going to go to modify, change parameters. You see I'm in the solid model space. I'm going to change my, let's see, I'm going to change my, let's say, what did I say, inside diameter? I wanted the hole diameter to be 3. Now we're going to run into a problem here, because as soon as I do this, my hole diameter is going to go larger than my flange diameter. So let's see what happens. It's going to give us an error. It's going to say it can't generate. Oh, it did, but look at that. It made a disc. We have a disc with some weird kind of shape. That's not exactly what we wanted, right? So let's undo that. Let's undo that if I can. There we go. Went too far. So let's go back to our parameters, change parameters, and let's do the same thing. Let's make it so our flange diameter is actually going to be our hole diameter. Let's say plus, I want to say plus 1/3 of our hole diameter. Okay, so here we have pretty much kind of the same thing we had before. It changed a little bit in size. And now if we modify our parameters and change, oops, hit escape, I didn't mean to do that. And then we change our hole diameter to 3 inches. And then we do have to change the inside diameter, and let's just say the inside diameter in this case happens to be 2.5. Okay, and here you can see we have a very large grommet, custom sized, to be put in whatever application you want. Let's just save this. So you'll notice something here as I'm working on this. I'm rotating and zooming in and out, and I'm not using the orbit tool or the directional orbit tool up here. It's because I have a space mouse. These are handy, especially for snapping in and out of different views. I love that. You can click on this to get it, but I'm a big fan because you kind of get out of whack really easily. This tool is all right. It works a little bit better. You can still get kind of out of whack. But the other issue is once you're in it, you have to escape out of it. And I like to be able to click and move at the same time, so I use an orbital mouse. 3D Connection has really good products. So mine is this. I think it was like $150. It's wireless. They do have a plug-in USB version too that's a little bit less. Definitely check it out. I'll put a link down below in the description. So yeah, that's that. This kind of makes me think about what are the next steps to do from this. So yeah, take this output it as a mesh file or an STL file, and put it on a printer that can do PLU. Print yourself up a custom grommet. Another option that you could do is you literally could make a mold out of this and then make it out of silicone, which now gives me an idea about maybe the next video tutorial. So let's think about that. So thank you for joining me on this short tutorial about using parameters and parametric design approaches just on a simple project like a grommet. Lots of other ways you can use it. I use it on a lot of different designs that I'm working on, especially when there's assembled components. So they're all related to each other. But this did give me an idea for what the next video could be, because I've done work like this before. Is we're gonna take a grommet design that we're gonna make. Maybe I'll do something a little bit more unique as the standard grommet, and we're gonna create a reverse of that, make a mold out of it, and then what that approach is for that mold, and then from there, make that. So then we'll 3D print it. And that'll probably be like a third tutorial, but we'll 3D print it, make a mold out of it out of 3D printing, and then use that to cast it in silicone. So that could be really exciting. So be looking for that video. And anyway, thanks again for joining me here at Alchemy Design, and hit the subscribe button. Love to have subscribers. Hit the like button, leave comments. I will answer them as soon as I see them. And again, take care and enjoy your designs.